Enantiomer is one type of stereoisomers in which the mirror image are non-superimposable. Okay, so the enantiomer will occurs only with the compounds whose molecules has a chirality center. So the chirality center here means that the sp3 hybridized carbon bonded to 4 different atoms or group of atoms. Okay, so remember the sp3 carbon must contain 4 single bond. Okay, and then it is optically active. So the optically active here is the ability of a substance to rotate the plane polarized light. So the other names for the chirality center, okay, we can call it as a chiral carbon, okay, or the asymmetric center or stereogenic center. Okay, so for example here, okay, this carbon and this carbon is the sp3 carbon, but only the second carbon here is the chiral carbon because this carbon is attached to 4 different atoms or group of atoms. And then the other molecules here is an example for molecules that contains 2 chiral carbon. Okay, so the chiral carbon can exist in one molecule. Okay, it's not just only one chiral carbon in one molecules. Okay, so boleh ada banyak lagi. Dengan syarat that carbon first it must have an sp3 hybridized carbon. It is an sp3 hybridized carbon and also it attached to 4 different atoms or group of atoms. Okay, for example here like this. Okay, so we have the for the first chiral carbon here we have CH3 group, hydrogen, OH group and also this group. Okay, so this is for the first chiral carbon. For the second chiral carbon, okay, this carbon we have hydrogen, CH2, CH3, OH group, and also this group. Okay, so that's why these molecules contain 2 chiral carbon. To see whether our cyclic compound got a chiral carbon or not, we are going to see if there is any difference in the path around the ring in each direction. For example, in our first compound here, so we have this carbon attached to the OH group. Okay, so we have OH group attached to this carbon, but then in others carbon, okay, so we have the identical group which is the CH2. So here we have CH2, 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 CH2 and CH2. So it is identical. So this compound got no chiral carbon. But then for the second compound, okay, so here we have the OH group. Okay, so we have the OH group and also the CH3 group attached to different carbon. Okay, so here we have hydrogen and OH. Here we have hydrogen and CH3. So since we have different group attached, okay, in the path around the ring, so it has a chiral carbon. So here we got 1 chiral carbon, here also we got 1 chiral carbon. So in this compound there are 2 chiral carbon present. Okay, so molecule with 1 chiral carbon is a chiral molecule, but some molecules with more than 1 chiral carbon, it can be chiral or achiral. Okay, but for molecules with more than 1 chiral carbon, is not in the syllabus. Each molecule that has a non-superimposable mirror image is a chiral molecule. Okay, so if we put our chiral molecule in front of the mirror, so we can see these 2 molecules is non-superimposable to each other. Another example for the non-superimposable is your left and right hand. So if you put your left and right hand on top of each other, you can see that your left and right hand is not superimposable, but they are mirror image to each other. The spatial arrangements of atoms or group of atoms within the molecules is significantly important in organic chemistry. Therefore, there are methods of writing structural formula in 3-dimensional projection. So to draw a pair of enantiomers, so we are going to use the 3-dimensional projection where the wedge line here represent the bond in the front. the wedge dash line here is the bond behind, and the solid line is the bond that lies in the plane. Okay, so we are going to use the 3D formula, okay, to show the enantiomers of these molecules. Okay, so now let's convert these molecules into enantiomers in 3D. Okay, so let's start with our chiral carbon. So I'll put my chiral carbon on the central. Okay, so carbon must have a tetrahedral shape. Okay, so the solid line, I'm going to put it here and here. Okay, so just draw it as tetrahedral. Okay, so and then the wedge line. Okay, so I put it on the front, and also I have the dash line here. Right, so the dash line, I'll put it here at the back, bond behind. Okay, so this is it. Okay, so after that I'll put the atoms or group of atom on each bonding. Right, so we are going to put the most simple atoms or group of atom on these two lines. Okay, so the simplest atom is hydrogen, so I'm going to put hydrogen here, and then followed by the OH group. So I have the OH group here, and then here and here you can put the CH3 or the carboxy group. It's up to you. So I'm going to put the COOH here, and then here I'll put the methyl, the CH3 group. Okay, so I've got one structure, and then now I'm going to draw its mirror image. So, okay, so draw the carbon first, and then the solid line. Okay, this and this bonding is the solid line, and then here I've got the wedge line and also the dash line. Okay, so the bonding at the back for the dash line. So next, I'm gonna copy back all the bonded atoms or group of atoms into this. So at the top here, I've got the COOH. Alright, so here I've got the CH3 group. Okay, and then here I've got the OH group, and for the bond at the back, I've got the hydrogen. Okay, so these two are enantiomers to each other. So let's have a look at some example. So write the 3D formula for both enantiomers of the following molecules. So for the first molecules, okay, it's better for us to expand it a little bit of the bonding to see whether our sp3 hybridized carbon got a chiral carbon or not. Okay, so for the first compound, okay, so compound A, so I'm gonna label my carbon first. Okay, 1 2 3 4, so I've got 4 carbon here, right? So 1 2 3 4. Okay, so for the first carbon I've got 3 hydrogen, and then second carbon here I've got 1 hydrogen and 1 chlorine, okay, as my branch. Okay, and then second carbon I've got CH2, and then third carbon CH2, fourth carbon I've got CH3. So all the carbon here are the sp3 carbon, but only this carbon bonded to 4 different atoms or group of atom, if you can see here. Okay, so this carbon is bonded to hydrogen, chlorine, CH3, CH2, CH3. So 4 different atom or group of atom. So this carbon is my chiral carbon. So I'm going to put the asterisk here. Okay, indicates that this carbon is the chiral carbon. So now I'm going to draw the 3D structure for the enantiomers of this molecule. Alright, so first I'm gonna draw the chiral carbon on the central, and then put the solid line here, and then the wedge line, the bonding at the front, and then also the dash line at the back. Alright, so then I'm going to put the atoms or group of atoms here. Alright, so on the top here, I'm going to put the CH2, CH3. Okay, so here I'm going to put the CH3. Okay, so at the back, I'm going to put my hydrogen, and here I'm going to put my chlorine. Okay, so always put the simplest atom or group of atom on these two lines. Okay, so next, its mirror image. Okay, so let's draw the bonding first. Okay, so the 4 bonding, right? It must be the mirror image of each other, right? So just copy back all the atoms or group of atoms, okay, for each bonding. So at the back, I've got the hydrogen, here I've got the chlorine, and here I've got the methyl group CH3. So these two are the enantiomers for this molecule. For the second molecules, okay, so let's label our carbon. Okay, 1, 2, 3. Ignore the one that in the brackets. Okay, so we have 4 carbon here, right? So let's open up the structure a little bit. Okay, so carbon 1, carbon 2, carbon 3, and carbon 4. So on the first carbon, we got the CH3. Second carbon got 2 hydrogen. The third carbon, we got 1 hydrogen, and another one is CH3. Okay, so next carbon, we got CH2. OH. Okay, so from here we can see all the carbon are sp3 carbon, but only this carbon bonded to 4 different atoms or group of atoms. So this carbon is a chiral carbon. So we are going to draw the 3D structure to show its enantiomers. Okay, so first, okay, so let's draw the solid line, the wedge line, and also our dash line. Okay, so let's put the simplest atoms or group of atom here. Right, so we have hydrogen and also CH3 group. Okay, and then here I'm going to put the CH2OH. Here I'm going to put the CH2CH3. Okay, so its mirror image. Okay, draw the mirror image of the structure, right? Okay, so just copy back the atoms or group of atom that is bonded to this 4 bonding. Okay, so here we have the hydrogen, here we've got the CH3, and here we have the CH2, CH3. Okay, so these are the enantiomers for the second molecules. Polarimeter is a scientific instrument used to measure the angle of rotation caused by a passing polarized light through an optically active substance. So, compounds that have a chiral carbon have an ability to rotate the plane polarized light. So, we call it as an optically active substance or compound. The optically active isomer, which rotates the plane polarized light to the right direction or clockwise direction, is known as dextrorotary isomer or positive isomer. Okay, while the one that rotate the light to the left direction, the counterclockwise, we call it as levorotary isomer. Optical isomer also can exhibit in different chemical behavior. For example, here we have the enantiomers of limonene. For the dextrorotary limonene, okay, the positive limonene, it has an odor of orange, while the negative limonene, it has an odor of lemon.